Hi, everybody. Now we are going to talk about chapter 3, that is the IT building blocks, the hardware part. In chapter 1 and chapter 2, it was an introduction, and we mainly mentioned that there are four IT building blocks and related to information technology that includes the hardware, software, communication, and data. So the core topic for this chapter, which is chapter 3, is the hardware. And there are two main topics that we will cover, which is the hardware components and the types of computer systems. Now, we can define the hardware as a building block as a physical components or all physical components that constitute the computer system. Now, the computer system is or consists of 6 main units, and actually, it's not just a computer system. Every computer hardware consists of those 6 units. That includes the input, the output, the memory, arithmetic logic unit, and control unit, and files or storage. This diagram illustrates, or the following diagram illustrates to us how those components interact with each other. So let's begin with the first topic, the hardware components. And from the diagram, as you can see, the control unit or the arithmetic logic and control unit, they are like the master or the brain of the computer system, because they interface with every other component that includes the input, the memory, and the output, as well as the storage. So all computers are made up of those 6 units, and definitely we can combine the control unit and arithmetic logic unit, and we could refer to them as the CPU. So the CPU, or the central processing unit, it could be referred to as the control unit, and the arithmetic logic unit, that are the head or the heart or the brain of the computer system. Now let's go and start with the input as the first components. So the inputs are considered to be all devices that we use in order for us to enter the data into the system, and those are not just limited to the keyboard that we normally use. There are many different components that can be utilized as an input device to the computer system. We can, of course, mention, for example, an input device example, the keyboard, of course, the main unit that is so popular, and utilizing the keystrokes for input. Of course, the mouse, the touchpad, those are considered to be an example of the input devices. Disk drives and flash drives, when we use them to add data, or when we use them to read the data into the memory, they are considered to be an input device. So they are an input device to the memory and therefore the computer. Magnetic ink character recognition, or MICR, they use it in banking, especially for reading bank checks. This is also an input device. Barcode labeling and barcode reader, of course, and the barcode labels that require a barcode readers. Those are devices that can be used to scan the barcodes on packages or products, and take that data or read the data to the computer system. We have also optical character recognition devices, or OCR, that directly scan whatever has been typed or printed, and then it translate or transform those scanned into certain kind of character or images that can be used by the computer system. Imaging also considered to be an input devices, because the also could be used as a scanned documents or photos, and they can be transferred to the computer system. One thing that we need also to refer here, it's good to identify the comparison between the terminal and a PC. It's good to mention that the terminal is different than the PC, because the terminal consists of only the input and output that could be attached to the PC. So the terminal, we can say it's designed strictly for input and output, and it has a keyboard and screen, of course, does not have a processor that can be connected to a certain processor via a certain kind of telecommunication. Now, a very good example of terminal is the automatic teller machine and point of sale terminals. All these are considered to be terminals. So it's good just to mention those because to differentiate between the PC and the terminal. We move on to the second component of the hardware, or the second unit of the hardware, that is the output. Output, of course, from the name, it produces results to us in certain readable format, in usable format. Now, as we have mentioned, there are many examples for input devices. Also, there are many examples that we can mention related to the output devices. Now, one of the major one, of course, is the video display unit that we use to read that's used to display the information that is generated from the computer. Now, another unit or another device that we can refer to is also the disk drive or flash drive. We mentioned that the disk drive and flash drive are used as an input devices. They also could be used as an output devices. How? Because they can receive data from the memory. So when they receive data from the memory, when you store data in the storage device, they become as an output devices. The printer, when you want to generate an output in a readable format, that's where you use the printer. So the printer, this is a good example of an output device. Also, there is computer output microfilm that is generated for archiving copies in small space. You can say also a tape backup solution is considered to be one of the example also, or common example related to the output method. Voice response unit that is also used to computer generated verbal responses or to generate messages. Those also considered to be an output method. So they take the voice and then they generate certain verbal response messages in the system. We move on to the third component or third unit of the hardware as an IT building blocks, which is the memory. Memory, of course, is acting between the input-output devices and the central processing unit, or the CPU. Now, we could refer to the memory as the main memory or the primary memory. Now, all data flows to and from memory, of course. We use the memory as an intermediate step before processing the data at the CPU. So we can say that the memory is divided into certain cells, and each cell has a unique address that can be referred to or referenced by. Now, think about it that, the data are being stored in the memory, and there are addresses related to each cell of the memory. And when we store the data, we refer to the data by the address name. Now, this diagram here, we have a nice diagram that divides the memory into different cells, and there is an address for each cell. Now, here, we need to remember that the data could be at different sizes. Now, the data could be the data could be stored in the memory as 1 byte or as a word. Now, a byte that consists of 8 bits, that stores 1 character of data. Now, a word could store 2 or more characters of data. Now, each memory cell, of course, is considered to be a set of circuits. So it is not just like units or cells. They are definitely an electronic circuits, that can be charged of different level, different value, for example, on or off, that could be represented by 1 and 0. Now, each circuit corresponds to a bit or binary digit. So we can say that most computers, of course, they use 8 bits or 8 circuits to represent a single character. So each character could be represented or will be represented as an 8 bits, and this is what we call it the ASCII character technique. And of course, there is other technique beside the ASCII, which is the EB or extended binary CDIC technique that is used for encoding or representing the data or representing the characters. So the characters, in order for us to represent them, and we can use the ASCII that is based on 8 bits, and we can use the EBCDIC system that's also similarly in a similar fashion, but it uses 7 bits instead. Now we move on to the next component, which is related to the units. We talked about the input, output, and memory. Then there is, of course, the arithmetic logic unit. We can say that there is the arithmetic logic unit as well as the control unit, so there is the control unit and arithmetic logic unit. So we can say that they both constitute or represent the CPU. Now, for the arithmetic logic unit, or ALU, it carries out mathematical operations. So it is used by the CPU to execute mathematical operations like addition, subtraction, or multiplication or division. And in addition to those mathematical, it does also logical operations, includes the and, the or, type of logic. Okay, and usually it consists of very large scale integrated circuits on a silicon chip. So this is the arithmetic logic unit. So it also can perform many operations per second. It's also measured in billions of operations per second. So the number are taken from memory as an input, and the results are stored in the memory as an output. So that's why there is an interface between the arithmetic logic unit and the memory, because the data is being moved back and forth from memory to the arithmetic logic unit. So it goes from memory to be processed by the arithmetic logic unit, then it comes back to the memory as a processed data. We can also talk about the control unit. The control unit is the device, or it's the unit that is part of the central processing unit that controls every other component or every unit in the computer system. We can also talk about the computer files or the storage. The storage is as we mentioned, the data are being transferred between the CPU and the memory, but they need an additional area where you store the final data, the final output. So you need a permanent way to store the data. That's why we use storage, or we call it sometimes computer files, or we store them as computer files and folders. So the storage or files or computer files, these are devices that is used to store a huge amount of data that is different from the main memory, which is of course limited to a certain size, and it is volatile and expensive as compared to the full storage unit. Now, the advantages of the storage is that file devices or secondary memory are used to store additional data. First of all, it is not volatile, so it is permanent. It could preserve the data without being lost, even if you turn off the power. Now, disadvantages of the storage or the devices, the file devices, it has a slower speed than the memory. It's also storage devices. It depends on certain kind of magnetic tapes. For example, it uses certain technology, then it's different than the memory. Now, example, of course, of these devices include magnetic tapes, disk drives, floppy drives, or even optical CD and DVD drives. Now, the way that we read from those storage devices, we read using two different methods. We can use the sequential access file. so we can access the data in a sequence or sequentially. The other method is direct access file, is that we access the data in a direct method. It's not in a sequence. Now the sequence again records the data are stored in sequence and to file control key, usually stored on a magnetic tape. So the magnetic tape is a good example of sequential type of access to the files, because the files are being stored in a sequence of order. Direct access files records the data on different spots or different area without regard to the physical location. Now, stored on direct access storage devices, we refer to it as DASD, which stands for direct access storage device. Now, that could be an example of this. A good example of that is the CD-ROM, the DVD-ROM, the CDR, DVD-R, and all these the CD writable devices. We can also consider the removable drives, which is floppy drives, zip drives, flash drives. All these are what we call solid state that could implement what we call it a direct access technique. And the final unit, of course, as part we mentioned before, the input. We mentioned the output devices, we mentioned the memory, we mentioned also the arithmetic logic unit, and we discussed the storage devices, which is that includes the hard disk drives and the floppy disk drives and the solid state devices and magnetic devices. Then we finally there are the control unit. Now the control unit is the brain, as I mentioned before. So the control unit, and it has it controls all the other 5 components that has been mentioned before. It is used to take advantage of the speed and the capacity of other components. And we can use the control unit to list different kind of operation, what we call it programs. Okay, so it can tell the control unit what to do. The computer program utilizes the control unit. It can list what is needed to be done for the application, and of course the computer program is what we call it a high-level language that could be translated into the machine language that is understood by the control unit. So the machine language is a computer program written for a specific computer model, and program executed by the control unit consists of operation code and address. Okay, and now here we need also to mention something about the CPU or the control unit or the arithmetic logic unit, that they are measured in million instruction per second, or MIPS. So million instruction per second, or MIPS, is a way to measure the computer power that is represented by the CPU and the internal hardware. Now, there's also millions of floating point operations per second. This is related to mathematical operations, so it's abbreviated as MFLOPS, which stands again for millions of floating point operations per second. These are all benchmarking tools that can be used. We finished the first topic, then we move on to the second topic, which is the types of computer systems. Now, we discussed before in chapter 1, chapter 2, different type of computer system that includes microcomputer, mid-range system, mainframe, and supercomputer system. And this table here, I have a nice table here that represents the different category and the average cost and how many MFLOPS, or what is the benchmark for those systems in comparison with each other, as well as the primary usage of each system. As you know, microcomputer is used as a desktop, the PC that is used in the business, and as a web client, as client server for running client server application at home. Mid-range system is used by corporate environment that runs their application or corporate application, including office automation, CAD, graphics. It can run as a server, of course, web servers. Now, the mainframe environment. It has different also characteristics as compared to the other two, the microcomputer mid-range. The mainframe system they are expensive. They could reach the cost could reach $500,000, start with $500,000, goes all the way up to the $20 million range. And finally, the supercomputer, they are extremely fast. They utilize very high processing power, and they run in the range of between $1 million, and they can go up all the way to $100 million. Now, those being illustrated here, there are many different examples about microcomputers and the different components related to the mini computer or mainframe environment and supercomputers. Now, I just want to mention something about supercomputer. The supercomputer is used for high processing power. It handles very sophisticated problems. It is used in research and development. The cost, as I mentioned, that could range from $1 million to $100 million. And a good example for that is the IBM Blue Gene/P, which utilizes, by the way, almost 300,000 processors and can achieve a speed of 1 petaflop. I think we have reached the end of chapter 3. Thank you.